Hello and welcome to the Pedagogic table. Potassium was discovered in 1807 by Sir Humphrey Davy. The name is derived from the English word potash, which refers to an alkali extracted from a pot from ash of burning wood or leaves. One of the most reactive and electropositive of all metals is potassium. The metal is silver white and soft. Potassium has to be stored in mineral oil, for example kerosene, as it oxidizes in air and catches fire spontaneously when exposed to water. Potassium and its salts colors a flame violet.
Okay, so now we're going to do a second test here for the element potassium. What we're going to do is a simple flame test. And what we're going to do is we're going to simply soak this wooden stick in a potassium salt. In this case it's potassium chloride containing potassium ions. What I'm going to do now is simply add it into the flame, and what you'll see there is actually a change of colour. The reason for the change of colour is because electrons in the potassium ions are being excited. They're jumping up to a higher energy level, and when they fall back down they give out the energy as light, and that light we can see. And we see this light for potassium as being violet colour. So see if you can see the violet colour here. So
Potassium is the seventh most abundant element on Earth. It can be found in the Earth's crust as mineral compounds and salts. Potassium does not occur freely in nature. Organically, it can be found in fruit, vegetables, and leguminous. Pure potassium metals are rarely manufactured, except for when making potassium superoxide. International production of potassium compounds, however, is vast.
Right, so now we're going to look at another metal which is in group 1, and that is potassium, chemical symbol K. Both elements, sodium and potassium, have one electron in the outer shell, but potassium reacts much more vigorously with water than sodium. So we're going to here cut a small piece of potassium metal. Like sodium, it's a very, very soft metal. You can easily cut it with a knife, and it has a shiny metallic appearance. Now we're just going to drop it into the water, and you observe it has a much stronger reaction than sodium's reaction with water.
Because of potassium's low electronegativity, it is highly reactive, and is therefore used as a reducing agent. Potassium hydroxide plays an important role in nutrition in plants, and is therefore used in fertilizers.